So hello guys, welcome to my channel. Today in this video I will discuss about the second problem of today's Leetcode contest, that is the number of special characters too. So before moving towards the problem, let's talk a little bit about myself. My name is Shushil De. I am specialist at Code Forces and Knight at Leetcode. So let's read the problem statement here. So you are given a string word. A letter C is called special if it appears both in lowercase and uppercase in word, and every lowercase occurrence of C appears before the first uppercase occurrence of C. Okay, that means you are simply given a string word, okay, and the particular letter C is called special if it appears both in lowercase and uppercase, and every lowercase occurrence must be present before the first uppercase occurrence of C. Okay, so for C being special, the lowercase occurrences must occur before the first uppercase occurrence, right? So let's see the, and finally I have to return the number of special letters in word. Okay, so let's see the first example here. So in the first example, the small a, let's select the pen here. Okay, so here the small a is present before the capital A. That means all the lowercase occurrences are before the first uppercase occurrence. So A is a special character. Okay, A is special character. Here small b is present before capital B. That means the lowercase occurrence is before uppercase. That means it is also considered as special, and C will also be considered as special because the lowercase is occurring before the uppercase. That means there are total 3 special characters. Now let's see the second example. Second, okay, the second is simple. Let's see the third example. Then this will be much more clear. So here let's select the pen. So here small a is basically present after capital A. Okay, that means it is not special because for being special the lowercase occurrences must present before the first uppercase occurrence, and small b is also present after capital B, so B is also not special. So A and B both are not special, and there are no lowercase occurrence of C. That means there are 0 special characters, right? There are 0 special characters, and see here the answer is basically 0 as there is no special characters in word. Okay, so to solve this problem, what we will have to do that, first observe a thing, that here the lowercase occurrences must present before the uppercase occurrences. Okay, so if we take a map of lowercase alphabets where where we will store the last occurrence of the lowercase alphabet. Okay, that means mp of I basically store the last occurrence of lowercase. Okay, and taking another map in which we store the first occurrence of uppercase character. ठीक है, a second map where we store the first occurrence of uppercase character. Okay, and name these two map as one is lower and one is upper. Okay, this lower map will store the last index of lowercase characters, and this upper map will store the first index of uppercase characters. Okay, and for a particular character C, if the lowercase indexes, that is the last index of the lowercase version of C, is less than upper of capital C, that means all the lowercase characters must be present before the uppercase characters of C. If the last index of lowercase is less than the first index of uppercase, that simply signifies that all the lowercase character must be present before the uppercase character. Okay, and if this is happened, we will increment our counter. Okay, and this will definitely be our answer. So what we will simply do, we will declare two maps. One is named as lower and the other we will name as upper. Okay, in lower we will store the last index of the corresponding lowercase character, and in upper we will store the first occurrence of the corresponding uppercase character. That means we will simply run a loop from I is equal to 0 to I less than n, where n is basically the length of the string. Okay, n is basically the length of the string, and now we will store lower si equal to I. Okay, and this will eventually store the last index of the corresponding lowercase characters. And there here we have to write if statement that si is greater than equal to small a and is then equal to small z. That means this is lowercase character. Otherwise, if it is not lowercase character, then else we have to store it in our upper map. So to store it in upper map, we at first we have to check whether we already visited it or not. Okay, because what I have said that in upper map we store the first occurrence of the uppercase character. Okay, so to check whether this is the first occurrence or not, we simply have to check whether we have visited it in for the first time or not. So in upper map we will check whether si equal to upper dot end or not. If it is the case, that means this character is occurring for the first time. Okay, in that case we will simply do update upper si with the corresponding first index of occurrence. So by doing this, in the upper map we are storing basically the first occurrence of the uppercase character, and in lower we are basically storing the last index of the corresponding lowercase character. Okay, and then we will simply run a loop, okay, from small a to small z, like we have done in the previous question. And then by using the concept of ASCII values, we will find the corresponding uppercase character by minusing 32 from I. If you are not able to understand this, please check my previous video where I have explained clearly that what I am doing here for finding the corresponding uppercase character. Now we will check here whether this particular lowercase character is present in the lower map or not. That is I not equal to lower dot end, and this lower I must be less than upper I, right? That is, the lowercase occurrence must present before the uppercase occurrence, and if that is the case, we will increment our counter, and finally we will return that counter. Okay, so let's move towards the coding part, then it will be clear more. So let's start to do coding. First declare two maps. We call one as lower and the second map in which we will store the first occurrence of uppercase character will be named as upper. Okay, next we will declare a variable n and store the size of word in n. Then we will simply run a loop. Okay, that is, we will basically iterating through the string word. Now we will check if word I is greater than equal to small a and less than equal to small z. That means it is basically we will checking whether it is lowercase or not. If it is lowercase, then what we will do, we will simply store it in the lower map, lower word I equal to I. This will eventually store the last index of lowercase character. Okay, else if it is uppercase, we will check whether we have already visited it or not. So we will check here whether it is already present in the upper matrix or not. If it is not present in the upper matrix, that is, if we using the find function, if upper dot find word I equal to upper dot end, that means this is not present inside our map. In that case, we will simply store that particular index, that is basically the first index of uppercase. First index of uppercase. Now here we simply run a loop from small a to capital Z, and here we will find the corresponding uppercase by using ASCII code. and eventually type casting it by this character. Okay, if you are not able to understand this properly, please check my previous video and I will give the link in the I button. Now we will check whether the lowercase character is already present in the lower map or not, and the lower I must be less than upper ch. That is basically the corresponding uppercase character of I. Okay, and we will declare a variable cnt here, and we'll finally return cnt. Here I have, okay, forget to give a second bracket here. Finally return the cnt. Okay, let's run the code. I think I have done some sort of mistake here. This will not be bool, this will be int. Okay, now I think it will work fine, as I am storing indexes, so it will be int data type, right? Now what is the error? It is giving 0. Okay, this will be not equal. Okay, I have doing a mistake here, because we will check that whether it is present, right? And I have by mistake there is equal to assignment, but we have to check that whether it is present in the lower map or not, right? So now I think it will accepted. Well, that's all. So the time complexity is basically will be order of n. Okay, because here we are basically iterating to the string, and here we will ignore the time complexity of map, because here the size is fixed, right? The number of alphabet cannot exceed 26. So we know that map takes logarithmic time, and as the maximum length of map can be 26, so we will simply ignore that, and the time complexity will be order of n. And here don't think that the space complexity is big O. Okay, the space complexity is constant, because here the length of map does not declare the length of word, right? I have also discussed this in my previous video. Here the length of map is basically constant. Okay, that is ranging from 0 to 26. So the space complexity is big O1 here.